Hey guys, Mr. Wooten here again. We're going to look at the next question from outcome 4. This is question number 2. And our problem is very similar to the first one. It gives us a quadratic function. In this case, the equation is f of x equals x squared plus 6x plus 9. And what we're asked to do is to, again, find the x-intercepts, the y-intercept, and the maximum or minimum point, and then to graph it on our x and y axis here. So what we're going to do is jump into this just like we did the last time. Again, easiest way to find the x-intercepts is to attempt to factor the equation. Right? We set it equal to 0 because when we're talking about the x-intercepts, it's on the x-axis, so the y would have to be 0 if we're talking about the x-axis. So I'm going to take my equation, I'm going to set it equal to 0, and I'm going to attempt to factor this. So we're looking for factors of 9 that add up to 6. Okay, factors of 9 would be 1 times 9, or you can do 3 times 3. In this case, it's got to be 3 times 3 since that's the only pair that would add up to positive 6. So that means 0 would be equal to x plus 3 times x plus 3. All right. Now, when we look at each of these, if you remember from the previous problem, we're trying to figure out what value we could plug in for x so that we would get a value of 0 when we plug that in. So in this case, it should be pretty obvious. Negative 3 is the only thing that you can add to 3 to get 0. And then over here, we also get negative 3. Now, I've already written that x had to equal negative 3, so I'm not going to write it again. And anytime you're working on a problem where you end up getting the exact same x value from both parentheses, this is going to be a special case where there is only one x-intercept in this problem. Okay, that x-intercept is going to occur when x is negative 3, and again, y would have to be 0. We're talking about it being on the x-axis. Okay, so what that would look like is our graph is going to come down, and I know it's going to come down and go back up again as we talked about in the last video because we have a positive x squared term, which means the graph will open up. So that means it's going to come down here, turn at negative 3, and go back up. So this negative 3, since it is the only place where it crosses, there's no way it could go any farther down without having to cross back up through another point. So this is actually going to be our minimum point as well. Okay, anytime you have just one x-intercept, it's one of these special cases, your minimum point is actually going to be your x-intercept. Right? And then the only other thing I need to find is the y-intercept. Again, we can look at the equation. If it is simplified in ax squared plus bx plus c form, the y-intercept is simply the last number. Right? The number by itself, which in this case is 9. So I would go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, your graph will be a little more exact. I'm just doing a sketch here. But your point will come up through 9. I got a little sloppy there. And then it's going to come up on the other side over here. All right? So we have our point. Negative 3, 0 is the x-intercept and the minimum. And our y-intercept is at 0, 9. If you want to be a little more exact, you could just plug in some other values. Plug in negative 2, for instance, and see what you would get. Plug in negative 1, and that would give you a few more exact points to make your graph a little more accurate. But these are the key features and just a very rough sketch of a graph.